In this lesson, we'll use our knowledge of transformations to sketch some actual real functions. We're going to go through linear, quadratic, cubic, and quartic functions real quick. Starting with linear functions, use your knowledge of the function f of x equals x to sketch y equals 2x plus 1. Hopefully we know what this looks like already, okay, just using mx plus c, but we can imagine this as really 2 times some function plus 1. So my knowledge of the graph f of x is that it's a straight line going up 45 degrees. I've got now an a value of 2, which indicates to me a vertical dilation. Since a is greater than 1, it's a stretch, which means I'm going to be making all of these points twice as far away from the origin as from the x-axis as they are currently. Okay, so my graph's going to look something like this at the moment. Okay, everything is stretched by a factor of 2. Okay, it looks something like this. So this is y equals 2x. And then on top of this, I have a k value of 1, which means a vertical translation of 1 unit up. So to that blue line, I'll shift everything up 1 unit. So my completed graph is going to look something like this. This green one is y equals 2x plus 1. Everything shifted up 1 unit. So that's how we can use transformations to get an idea of what these functions look like. And hopefully you can see that this is passing through 1, so the c value is 1. It has a slope of 2. Every time we go across 1, we go up 2, which should satisfy my y equals mx plus c idea. So looking at some parabolas, some x squared functions, hopefully from the last lesson I'm drawing a million parabolas, you know that the base function would look something like this. A y equals x squared parabola. To this parabola, we can do some transformations. So if I start with my normal y equals x squared graph, the things that are happening here are we have an a value, like a vertical dilation, which is essentially going to either stretch or compress the curve. In this case, we'll just assume that a is greater than 1, so assume that it's stretching it up. And then from here we have two transformations. We're subtracting h, so that means we have a horizontal translation of h units. Because it's a negative value, it means that it'll be h units to the right. So my turning point here is going to move h units to the right, wherever h is. I also have a k value, which means a vertical translation of k units, and we'll assume that it's all positive, k units up. So that turning point, instead of being at 0, 0, is now going to be at this point hk, and I'll draw the same quadratic shape at that point. So we can see how this general form of a quadratic can be drawn by first stretching or compressing and then moving it around. The idea of this general form is that the turning point is at hk. Turning point at hk, which is really useful because then when I look at equations of graphs, I can automatically see where the minimum is going to be as long as it's in that turning point form or general form. So let's actually sketch some graphs. So this first one, I've got y equals x squared plus 3. This looks to me to be a k equals 3 value, which indicates to me a vertical translation. Okay, in this case, up 3 units. So I'll quite roughly sketch my x squared and then shift everything up 3 units. And draw that same indicative shape. This is y equals x squared plus 3. That's probably about as easy as these are going to get. Example B, slightly more difficult. This is indicating an a value of 2, a vertical dilation. Okay, since a is greater than 1, we're stretching. And we also have a h value here of -4, which indicates a horizontal translation. And in our case, it's going to be right 4 units. And I can do this other one at the same time as well. K equals 3. Vertical translation up 3 units. Okay, I'll do the vertical dilation first. So I need to double all the distances. This is away from the x-axis. Okay. And at the moment this is y equals 2x squared compared to my x squared. And then my final move after I've done my dilation is the translation. So right 4 units and up 3 units. So this point here will be my turning point, and I'll draw the same shape as the red curve. Okay, so this curve is my y equals 2 x minus 4 squared plus 3. Probably a good idea to get into thinking about what's the coordinate of this intercept. Okay, you could find this by substituting in x equals 0. 2, 0 minus 4 squared plus 3. 2 times minus 4 squared plus 3, you'll get something like 35. Okay, so you can mark on here that this is actually 35, and you can feel good about that. So you can see what the general shape of these cubic ones are that we'll start to draw using transformations. Here's what y equals x cubed looks like, and here's what y equals negative x cubed look like. Okay, why are we getting these weird shapes and not parabolas? Because if I put minus 3 in here, I'll get minus 3 cubed, which is minus 3, minus 3, minus 3, which will give me negative 27. Okay, down here, minus 27. Okay, just so you know why you're getting that sort of a shape. So to this basic graph, we can do those same transformations. Okay, I can have an a value, a vertical dilation, so I'll stretch this out and stretch it in this direction as well. Okay, and so that's my a value, and I can also have a horizontal and a vertical translation. Okay, if I wanted to do that exactly like the quadratic, I'd move it h units to the right and k units up. Okay, so this point here is still my turning point that I'm interested in, and I'll draw that same shape curve up there. And I'm sure your diagram can be better. Okay, so we can use this idea to sketch using transformations. So from my y equals x cubed graph, I see here a equals 3. Should be getting used to this now. Vertical dilation, okay, which means I'm going to stretch this guy out. Okay, because it's a stretch one, since a is greater than 1. And then I can have a look at my translations. H is -2, K equals -3. Horizontal translation 2 units right, vertical translation 2 units down. So I'll go over here 2 units right, and then down here somewhere 3 units down. Here is my new turning point. Okay, it's a point of inflection, but it's still a turning point. And I draw the same shape graph as I did in red. Okay, and here I've got 3x -2 all cubed -3. Key points to note: need to write my explanation of the transformations and do the dilation first, then any translation. Final type of graph to look at are quartic functions, x to the power 4 functions. This is essentially what they look like. Sort of looks like an x squared function, but it hugs the x-axis a bit closer, but then will increase a lot faster. See them side by side. Here's what a quartic and a quadratic look like. So the quartic stays low, okay, because we're having, say, a quarter to the power 4, so a quarter of a quarter of a quarter of a quarter, rather than the red line, which is just a quarter of a quarter. Okay, do some calculations and you'll see why all the ones less than 1, the quartic is a little bit, I guess, fatter towards the bottom. Not sure that's the right word to use, but anyway. But then it accelerates quicker because we're going to the power 4 instead of just the power 2. Okay, it's got a minimum point or a maximum point if we put a negative in front of it. Okay, this is what y equals negative x to the power 4 would look like. And we can do the same transformations. So if I give it an a value, it means that we'll be stretching everything up. Can do better. And I can also shift the turning point h units to the right and k units up, exactly the same as before. And draw that same curve. Okay, so let's have a go at sketching our last example. So I look at my function, I got an a value of -1 because there's a negative out there, which means I'm reflecting it in the x-axis, so flipping it vertically. So mirroring this shape, but upside down. Okay, so I've got y equals -x to the power 4. And then I just need to look at my translations. So that turning point is going to move 2 units to the right and 3 units up. Okay, and then I'll draw that same sad face of a quartic. Okay, that's it. Now have a go at these questions and we'll check your understanding in class.